Okay, today we're gonna talk about cylinders and cones. Now, guys, you could actually, this section is really sort of nice because turns out cylinders are like the pyramids and cones are like the, no, cylinders are like the prisms and cones are like the pyramids. If you think about it that way, you will see, like, we're gonna look at the surface areas, I mean the lateral areas and the volumes. You will see that it's really similar. Okay, so that's the idea. And that's why I said this section is not that bad, because it's really similar to those. Watch this. So just like prisms, we have right prisms and oblique prisms. Just like, I mean, cylinders have right cylinders and oblique cylinders, just like the prisms. You see how we have right prisms, and so we have right cylinders. We have oblique prisms and oblique cylinder, and all the vocabularies are really similar. You have the altitude, you have the radius, and so forth. Okay. Alright, so, but of course the only difference is what? In terms of cylinder and a prism. The base is now? It's a circle. Okay, and do we know how to find the area of the base? Yeah, it's pi r squared and so forth. Alright, so here's our first theorem. Who remembers the lateral area for a prism? Right prism. Yes, Narek? Oh, that's the pyramid. Okay, well, what about for a prism? Perimeter times the height, right? So anyone want to guess what the lateral area for the cylinder might be? Okay, a lot of you. How about, it's, like I said, it's really similar. How about, so if the lateral area for the prism, right prism is the perimeter times the height, what would then the lateral area for cylinder be? How about Emily? Any guess? Yeah, it's the circumference times the height. So there you go. And we know how to find the circumference of the circle, don't we? Yeah. It's 2 pi r, right? And times the height. There you go. Okay. So the lateral area, you don't have to write the whole thing. You could just write LA equals to 2 pi r h, you know, for sure. Yeah, that's up to you. Now, what about for volume? If the volume of a, okay, you're writing, okay, I'll wait. Okay, go ahead, write it down, and then we'll get to the volume in a minute. So, okay, so if the lateral area of a cylinder is 2 pi rh, what would then the volume of the cylinder be? Think about the volume of a prism. What's the volume of a prism, first of all? Jocelyn, do you remember the volume of a prism?
Area of the base.
Area of the base times height. Well, it's the same thing now, right? What do you think then the volume of the cylinder be, Kenneth? Well, the volume of the cylinder be. Base times height or the area of the base times? Area of the base times height is again same. Now, what's the area of a circle? Pi r squared. So it's exactly that, right? Here you go. So it's volume is equal to pi r squared times h, which is the same as area of the base times height. Okay? So write that down. I'll wait. So let's just recap a little bit. So what do we say here? What do you see over here? If you see this right here, you see a?
It's a cylinder.
Yeah, it's a cylinder really. Right? You see a circle, but if I do this, you can see that it's a cylinder, right? Now, in this cylinder, what do we say? The lateral area, LA, is going to be, of course, when you open it up, you basically get what? What do you get, guys? You get two. Yeah, you get 2 circles and a rectangle. And look, what is the length of this rectangle? It's the height of the cylinder. How long is this? How wide is this? Yeah, doesn't it wrap around this whole circle? Look, if I do this again, look, it wraps around exactly. So we know how long this width is. It's basically the circumference of the circle. That's why the lateral area of this cylinder is the circumference of the circle, which is 2 pi r times the height, right? You just basically get a rectangle. Does that make sense? And of course, volume then, of course, is you multiply the area of the base times the height, right? Then you get the volume of the cylinder, right? Area of the base times height. Does that make sense? Yes? All right. Guess what we're going to talk about next?
Cones.
Cones is correct. Okay, so let's go to the cones now. As you can see, cones are similar to the pyramid, right? You could have right pyramid, oblique pyramids. So for the cones, you could have right cones and oblique cones. And for right cone, look, notice slant height, right? The same thing as the regular pyramid slant height. Actually, do we even have lateral edge for cone? No, cone you just have slant height. It's the same thing, right? Now, what do you think then? Let's start with volume first. Do you remember the volume of a pyramid versus a cylinder? Remember I poured the water in and so forth? How much of a regular pyramid, if you were to compare the volume of a regular pyramid and a regular prism that has the same base and same height, how much bigger is the this prism is 3 times as big. In other words, the pyramid is 1/3, right, as big as the prism, right, that has the same base and same height. So any guesses for the right cone versus a cylinder? Jack?
Oh, for the ratio?
Yeah. Ratio of the right cone versus the volume of the ratio that has the same base and same height. What do you think? Versus the right cone versus a cylinder?
Oh,
Which one has more volume?
2 to 1.
You think it's 2 to 1? It's going to be the same as before. It's going to be 1/3. Okay. So yeah, it's 1/3 of it. So watch this. Here's the theorem. The volume of a cone, equals to 1/3 of the area of the base times height. Same as what, guys? Same as the pyramid. It's exactly 1/3. I actually have that. I could pour in water for you. And it would, when we have time, we could maybe. But right now, let's just go through this. But as you can see, it's the same way as right pyramid and the prism. It's 1/3 of it. I'm sorry. But yeah, we get there in a minute. Yeah. So I want to do this first because it's kind of like similar to what we did last time. Actually, it's 12/7 is actually similar to what we did with the pyramid also. But write this down. I'll wait. So this is the volume of a cone, just like the prism, right? 1/3 times the area of the base times height. What do you think? Okay, so let's go back to the pyramid, what we did last time. What is the lateral area for a pyramid? You guys remember? How many people remember lateral area of a pyramid? How do we get the lateral area of a pyramid? How about, let me see. You should all know this. You all did this for your homework last night. Nare? Yeah, that's the one you told me beforehand, right? Yeah, it is the 1/2 times the perimeter of the base times the slant height, L. You guys remember? And yet, guess what the lateral area for the cone is? Yeah, same thing. 1/2 times. Well, this time, do you have a perimeter? Guess what you have? Circumference. So 1/2 times circumference, which is 2 pi r times L, the slant height, right? So that's what we have right here. And as you can see, same as before. Now, what do you think they got this from? Thank you. So we got 1/2 times 2 times pi r times L, right? This is half times the perimeter times the slant height. How did they get this? Pi r L. Yeah, just canceled out. Half and 2, right? So it's just, when you simplify, you get pi r L. But this is, do you see how it's the same as what we did with the pyramid? It's the same exact formula, right? Half times the perimeter. This time it's the circumference times the slant height. Okay. So write that down. I'll wait. Okay. So I have given you all the formula. All the theorems for this section. There are 4 of them. Okay. So let's summarize this after you write it down. Okay. So let's summarize what we learned so far. So for prisms, who remembers how to find the lateral area for a prism? How about Jonathan? Perimeter times height is correct. Well, what about lateral area for a cylinder? How about Grace? Exactly, it's perimeter times height again, but it's not really perimeter, it's the circumference. Very good. Do you see the similarity? It's same. Okay. David is not here. How about Shanna? What about for the volume of a prism? How do you find the volume of a prism? No, volume To find the volume of a prism, you find the area of the base times what? Shanna? So times the height, right? It's the area of the base times height, right? So Shanna, what do you think the volume of that cylinder is? Let me give you a hint. The same as prism. It's the area of the base times height, right? Well, what is the area of the base for cylinder? For a cylinder, you have a circle, right? So what's the area of a circle? Yeah, so guess what? Volume is? Which is pi r squared times? No, it's the area of the, here. It's an area of the base pi r squared. You multiply that by height, which is h. Does that make sense? Yeah, remember? Circle. Circle, the area of the circle is pi r squared. Oh, I spelled it wrong. Sorry. Okay. Does that make sense? Shanna, do you understand? What's the area of the base for the volume of a cylinder? What's the area of the base? It's a circle, right? Okay, so it's going to be pi r squared times h. Would you not agree? Because in place of the area of the base, you plug in pi r squared, right? Does this make sense? Yes. All right. What about then total area? What's the total area of a prism? How about Brandon?
It's pH plus 2 times area of the base.
Yeah. So I just wrote LA plus 2B because it's the lateral area plus two other bases, right? What about cylinder? Hannah, what's the total area for a cylinder? Yes.
LA.
Yeah.
LA plus,
Yeah. Same as the total area for the prism. Do you guys see the difference? Well, not. Do you guys see the similarity? It's the same exact thing. Really. Yes? All right, let's move on to then the pyramids, okay? So let's look at then the similarities between the pyramids. What is the lateral area for pyramids? How about Brandon? You're right here. Yeah. What's the lateral area for pyramids?
Half of the area times
Not quite. It's half times the perimeter times the stand height. Do you remember, Brandon? Right? Brandon, then what do you think then the lateral area for the cone is?
half of 2 pi
Times?
so
Yeah, it's the same exact thing, right? Instead of perimeter, now you have a circumference of the circle, right? Again, let's look at the volume of the pyramid. How about Katie? What is the volume of a pyramid?
1/3 of the area of the base times the height.
Correct. It's the 1/3 times area of the base times height. You guys remember I poured in, right, the water 3 times to that cylinder. It fits 3 times as much, but it's 1/3 of it, right? Okay, what about the volume of a cone then? If that's true, how about Julie? What's the volume of a cone? 1/3 pi r squared h, which is the same as 1/3 times base time, area of the base times height. You see how it's the same exact thing? All right, what about then the total area for the pyramid? How about Joshua? Over here. How many base does a pyramid have? Yeah, so Yeah, you add them together, right? It's basically lateral area plus the area of the base, correct? Because there's only one, right? What about then total area for the cone? How about the other Joshua? What do you think? Total area for the cones?
Lateral area plus base.
Yeah, it's exactly the same, right? Same thing. Does that make sense, guys? Okay, do you see the similarities? This is really the same exact thing, right? Okay, any question? All right, so that's exactly the same thing as, right? Prisms are like cylinders and pyramids are like cones, right? They work exactly like. Now, here's what I want to do then. I want to talk about the lateral area of the cone first, okay? A little bit, okay? Here we go. So, I want to talk a little bit more about the lateral area of a cone. So, what do you see right here? Have you ever, now, what do you think is going to happen if I were to open this up and look at the lateral area?
Circle.
How many of you opened up the wrapper for the ice cream cone? What does it look like when you open it up? Yeah, what is that called? Okay, let's open it up here. Is this going to be a semicircle every time? No. What is this called? We learned this. Sector. Who said that? Very good. Jocelyn. It's a sector. Do we know how to find the area of a sector? And so that's what we're going to do right now. So let's figure out. So take a look at what we have here, guys. Now, look at what we have. We have a cone. If I were to open this up, now what is the radius of this big? What is the what is the radius of the sector? It's the slant height. Would you not agree? Now, let me ask you this. Here's the key to find the letter area. What is the actual arc length of this sector?
Are we going to do this for homework?
What do you guys think? One person see it. Go ahead. Everybody think about it as a group. I'll wait. What do you guys think? What is the actual arc length of that? I think you can find this. Go ahead. Everybody think about it. Okay, let me give you a hint. First of all, do you see why okay, here's my cone. If I open it up, you see why this is my slant height of this cone? Does that make sense? Okay, so that's my slant height right there. Now, think about this. I'm asking, how long is this length? Well, let me give you a hint. Watch this. Watch this. Okay, watch this. Here you go. When I do this, what does it wraps the whole base around exactly, right? Doesn't it? Okay, so can you tell me how long this length of this arc is? Hold on, where's it going? Oh, it's right there. How about Jack? What is that length? Arc length. Length of the arc. That's exactly right. Would you agree? Right, it's the same as the length, the circumference of the base, because it wraps around that base exactly, right? Does that make sense? Now, if I know this, and also I know the radius of this whole sector, right? Who could tell me how to find the lateral? How to find the lateral area, which means the sector. What is the formula for finding the sector of a circle? Who remembers? Grace? X over 360
times
2 pi r. Are you sure?
pi r squared.
Pi r squared. Okay. That's how you find the sector, right? Does that make sense?
Yes.
Yes, it does.
Sector with x degrees, right? For the arc, right? Arc is x degrees. Does that make sense? Now here we don't have x degrees. So what are we going to do? Well, here, what does that tell you? X over 360. That tells you how much of the sector we're talking about, right? By the way, could we fill this out for this sector that we're looking at?
Yes.
What is the pi r squared in this case? What is the radius in this case? L. So let me write this down here. Pi now is going to be L squared. So that part we're good. Now what are we going to do for this? Because do you not agree? Because aren't we looking at the area of this sector right here, guys? Yes? What is the radius of this? What is the radius of that sector? It's the slant height, right? Okay. Now, what are we going to do for x over 360? Because we don't really have the measurement of this arc, but we only have the actual length. Is there a way to figure out how much of this circle we have using the length of the arc instead of the measurement of the arc?
Yes. No.
I want you to go ahead and think about it as a group. Because this, what are we going to do here? So any idea as to how we're going to figure out, basically this x over 360 tells you how many percent of this circle we have, right? How much of it, right?
Yeah.
How much of this circle we have as a sector. So who can tell me what to do? How about Jordan?
Okay, so you know that the radius of the sector is the slant height. So
Yeah, it's L. Very good. The radius of this whole sector is L, yeah, and
so you can find the circumference of the entire circle.
yeah, I can find the circumference of the entire circle. Can I not? And compare those together, right? Instead, because I don't know the, I don't know what arc measurement of this arc is, but I actually know the length. So like Jordan said, Jordan, tell me what to write. So what am I going to write here?
X over 360 equals 2 pi r.
Yeah, 2 pi r over
2 pi l.
2 pi l, because this, right, I know, right, the ratio basically of 2 pi r over this whole thing, doesn't that give you how much of the sector I'm talking about? It does the same thing as this, doesn't it? Right? Don't they give you the same ratio? Right? So this time we gotta kind of be creative. We don't know the arc measure, so we just use the arc length. Yes? All right, go ahead and simplify. See what you get. I'll wait for you. Go ahead, everybody's fine. So you can see how many people got. What did you guys all get? And isn't that what we said the area of the lateral area was? Of this, okay. Look, 2's cancel out, pi's cancel out. You got L squared. This is over 1. L cancels out with L squared. So you basically get pi RL, right? Does that make sense?
Yes.
Do you see how we could actually figure out what the lateral area of the cone is? It's just pi RL. Okay. Any question? Does that make sense? All right. Now, when you do your homework tonight, please make sure you look at the example 1 and 2, even though they're pretty straightforward before you do your homework. Okay? That would help you. Any questions? Are we good? Good. All right.